Hello, my name is Hunter Bedwell, and today we will be taking a look at the facial recognition web-enabled camera. My group consisted of myself, Robin Shin, and Brian Dunn. So, without further ado, let's get into this. First off, we have the project objective, which was to provide versatility to a security device that is otherwise not seen on the marketplace for the reason that many cameras seen today are not customizable in these regards. By connecting an Arduino to a UVC standard camera, in our case it was the Logitech C270, we would not only ensure that the device could be suited to to suit the user's needs, but also extend it to other uses as well, including security and theft. However, as part of revision 2 for the project, uh, we also implemented web functionality, so a user is now able to interact with the device when they're not within the premises. They can interact with this while they're on the go, or even if they're at a remote location. So, moving into uh, the adopted solution became a culmination of various hardware components. The Logitech C270, as mentioned earlier, an Arduino Uno microcontroller, a PIR motion sensor. Link's Motion Pan Tilt Kit was also added as part of the web functionality feature. Uh, the the reason behind this initially was for uh, you would go to the web GUI and then moving the sliders for the corresponding servo would turn the Link's Motion Pan Tilt Kit, and on top of that Link's Motion Pan Tilt Kit, you would have your PIR motion sensor and your camera, so you would be able to alter the camera's field of view with respect to the region or area that it's guarding. And as another part of this, we were also using Amazon Web Services, which would in turn enable local events such as photos returned through the camera snapshot functionality to be sent abroad to the cloud to be analyzed for evaluation. So, what this evaluation would do would determine what the user receives back uh, in their email text stream, depending on what the result would be. So, in the case that the camera detects a face feature that is already listed within our pre-populated database on Amazon, it would let the user know that a familiar face would be found, followed by, say, their name, and then in the event of a true negative event, it would return that the user is not found and that the user is an unknown entity. So, as far as problems we encountered along the way, the first issue we encountered was sourcing a 5-volt DC micro USB wall adapter. This was for the reason that the Arduino Uno Rev 2 that we used was it lacked a 5-volt regulator inside of it, so we had to look for something that was regulated for the reason that anything more than 5.3 volts probably would have began to cause damage to the board. Sorry, the microcontroller. For our second hurdle, we had under-resolved servos as a result of everything being powered from that single 5-volt wall adapter mentioned earlier. So to counteract this problem, we also had to add a breadboard and an additional 5-volt battery pack, which allowed for the grounds of both sources of power to be connected, hence giving the servos the optimal current that they had required. Good afternoon, my name's Hunter Bedwell, and I'll be giving you a short overview of my project. So, looking over here, we have the basic components outlined. So, here, let's start with the 5-volt battery pack. This is primarily to provide optimal amperage to these two servos, which were added in revision 2. Uh, this is a Link's Motion Pan Tilt Kit right here, which is used to maneuver the camera to view different angles, if you will. mounted on the front of the camera here is the PIR motion sensor, which is how we will receive motion data in order to trigger snapshot capabilities. And lastly, mounted on the Lynx Motion pan tilt itself is the camera, which will be the primary means by which we take the photo, which will then allow the picture to be stored locally on the Arduino Uno here and abroad on the Amazon cloud. Moving to the web functionality of the project, here on the web server you'll find two servo positionings, one for the X servo and one for the Y servo. Essentially what editing these two will do is alter the orientation of this pan tilt to display a variety of ranges from left to right and up and down. So I will try to show you this functionality in more detail. So here I am altering X servo. And as you can see, the changes are displayed accordingly in real time. Let's try another angle. How about, say, 45? So right now the PIR motion sensor is picking up motion data, so sometimes it takes a little bit to reacquire another process through the client. So let's say for Y servo we also try 150, and that makes a move downward accordingly. Lastly, we will be covering the Amazon recognition functionality built into the camera device. So essentially what is happening here is the images that are found in front of the camera are being compared on an image-to-image basis with those pre-populated into the database. So positioning myself in front of the camera will yield a text message and an email to those pre-specified to the algorithm. So looking here, the device was able to recognize me with 97% similarity. You can see here that the camera repeatedly found me, so sometimes it can get a little bit spammy. As for the email services, let me get this up real fast. So looking at my Gmail, it appears that a known face has been discovered, and you can see that it was from 0 minutes ago. Most of these are, since they were in a short time frame. And downloading the image yields an image of my face. So that is the positive yielded result. So to test the true negative qualities of this camera device, I decided to find a picture, HD picture of Will Smith on the internet. So I'm going to try to see if the camera can try to pull any existing records up on this particular facial characteristics. So placing this image in front of the camera, we will see what the results yield. Alright, so 30 seconds later, we do get a true negative result to pop up. So looking at our attachments here, we are presented with images of Will Smith. That one's kind of blurry. All of which point out that the face was not found within the database and that it has been classified as an unknown face as an alternative to that which has already been filled in, which in that case the name would be visible. This image, there was no face visible.